methods or the numerical concepts of it before the machine learning can really understand, because most computing are designed the way that it works in numbers. So obviously, if you're writing in words, we need to find a way to bring it back to numbers so that the computer can understand. So the first one will be import, and that's as what PD, and we import numpy as NP. So we should enter, and if this thing works very well, once you import, let's check that okay, it's running. Then we do for our sklen. So we import sklen models and vectorizers. So we do is sk. We first have to look from sk. You can do this control shift to bring the redefined on the help. That's what I call it. Shift another shift. Then we have a lot of sk models, but the first one that we've been extracting is called the feature extraction. So this feature extraction will be explained later. From imports from so later this feature extraction, we import a text there and import the TF, IDF, it's right. So after taking this one, we do same for sklen model. We extract a model, and the model a model selection, and import from train text split. And our next import will be from sklen again. We do a linear model and imports logistic regression. So this logistic regression help you to provide the hyperplane. After training our data set, you're going to provide a hyperplane also called the line of best fits, and based on this line of best fits, we draw a conclusion or draw predictions out of this line of best fits. So if the data or the line of best fits data is very close to the hyperline, the prediction is that close, right? That's why we can use probability testing to analyze the system very well. So equally, this logistic regression is used for training, testing, and also prediction. So we train our model, we test the model using this line of best fits, and we predict with this logistic regression. Okay, once this is done, we do another shift enter. It's reads and says no. Now let's move on to read the JSON file from the data set. So we read the train JSON file. That's it. We use pandas to read this. So pandas is a framework that help you to read external data sets, external files in our machine learning algorithm. So let's write data frame, because when we read the JSON file, we're going to get a data full of data sets called a data frame. Now we do PD dot read JSON, come here, JSON file, then navigate to our data set. Right, good. So equally using flask, flask API underscore. So it depends on the location of file. Then go to our data sets. Then we take our train model, train using data, and we do a shift enter to read this data set. Once the data set is read, we see whatever is in we check the list of elements that are in the data set. So we do a data frame, and shift enter again. So this is how. So one of the reasons why Jupyter's bulk is quite popular when it comes to machine learning, because we don't have to worry ourselves by running the entire code. We can run the code piece by piece. So with this data frame, we have this idea of the exclusions, we have these ingredients as we saw in our train JSON file. Good. So after reading all this data set and also getting the data frame, we can also call the first 5 elements here by doing just typing data frame dot head and underscore and just enter. So this is the first 5 data set here. Now our next move will be training, right? So first you have to combine all these data sets as one. So the TFID, so the TFID works in a way that we take a sentence, let's say new code is working on recommendation system today. So that sentence TFID will necessarily locate the unique words in the sentence and also some stopping words, as in yes, these stopping words will be neglected or ignored, and we also count the total words in the sentence and do some probability testing there and generate the usefulness or the frequency distribution of every important word in a sentence. So it's understood, but I think as we go further, I'll be covering a video about just the TF-IDF so that you get the concept very well. It's very popular and it's also very powerful when it comes to taking data set from users when they type or characters, not words, but just characters, group of characters. That's why I elaborate on this TF-IDF to help we analyze the data very well. So, but before you can start, is it that all these data sets are being grouped in an array, right? So you can see these ingredients are grouped in the array. So what you do is you have to combine all these ingredients, the ingredients into a combined ingredient, so that they'll be in a way that we'll be having a row 9 lettuce, black olive grapes, apples forming a sentence, and then we can use the TF-IDF vectorizer to analyze the importance characters here or importance words and perform some numerical concept there. Without that one, it's quite difficult to do this. So first off, you have to combine all this into a sentence. How do you do this? We do that by doing data frame. Then let's call this combine underscore ingredients. And we push an equal to sign and do a data frame. Data frame, I'm picking the ingredients. And what I pick in the you want to apply, right? You want to apply lambda x. And what we want to do, we want to join its x. So if you really see how this code is going, so you can see that from here we're having this column name as what ingredients. So this ingredient is having a lot of ingredients there, and based on each ingredient, based on each x-axis, each one, we are going to combine everything there, the x element there, into what's a single by leaving no space between them, like this. So leaving no space between them, and it's going to combine them as sentence. So what you do is shift enter again, and it reads. Once it's read, we can just go back our data frame dot head and see the new changes. So you can see from the here, you can see that our data set is now changed from what this ingredient. So we are having this ingredient there, right? And now it is being changed to a command ingredient. So the command ingredient is this way. So now that we have this ingredient, we can use our TDF to take the importance words out of this and also work on the recommendation system here. So let's start. We first have to initialize the TF-IDF vectorizer. So first initialize the TF. So TF, that's the transverse base word. So IDF vectorizer, we can put it underscore this way, small sentence, and sorry TDF, and which equals to sign, we take the TFD vectorizer, which can be found here as we initialize that one. We see that we initialize this one, right? So after initializing this one, we are using this. So with initializing, we have to target or ignore some stop words, like common English stop words. So based on the sentence that we have, the Roman lettuce, black, olive, tomatoes. Based on that one that we have, so based on this that we have, Roman lettuce, black is grief. If there is there at common English language, it's going to ignore. So if there is none, then it continues. So after initializing, what again do we have to do? After initializing, we then work on the combined ingredients. Since that is the sentence form of all the ingredients, right? So since that is the sentence form of all the ingredients, we just enter and do this. So when TDF works on a sentence, it creates a matrix, right? It creates a matrix. So the matrix is informed that the matrix have total numbers or total words in the sentence and also the unique words. So the most important part of this TF-IDF vectorizers is that it's going to navigate the most unique words there and also the total words and perform some probability frequency distribution among these texts. So we do this by going TF-IDF. I think it's too long, but let's keep it cool. Matrix equal to the TF-IDF vectorizer that we have. And what I'm going to do, so we will first have to fix, that's laying the sentence that we have. So it's going to lane everything here, and after laning them, we do what? We fix and transform it into what's in the matrix. So we lane all the sentence by analyzing Roman letters being so all the sentences will lane, and after being linked by the TDF vectorizer, then we can transform it back to a matrix. That's the 2x2 matrix. So we pick the data frame, then we go to combine ingredients. So when you enter shift enter, it's going to read. And okay, so once this fits, you're going to check if FIDF vectorizer matrix really works. You want to see the total number of words there, and also so check the TF-IDF total number and the unique words. So how do we check that one? We check that one by doing this very simple TF-IDF matrix that we have, and also we do the shape. So the shape is going to give a 2x2 matrix. So shift enter, and I'm going to get 3,974. I think 39,774 total words, and these are the unique words there. So since you have this data, we can now do what? We can now start training the model by navigating through X and Y. And so we first allocate X to these unique characters that we have, because these unique characters will be easy to be trained by. Because we want to train all these duplicate sets. Let's say I have oil, true, or water, true, out all the ingredients. I guess we only need one water to train it. So anytime I see water, I can say, okay, this water is an ingredient, and based on this ingredient water, I can predict the Y components or equations, because we predict equations. So our next step will be, that we are going to initialize both X and Y data. So there's our X data will be equal to the TF-IDF matrix. That's good. Then the Y data will be nothing but what you want to predict. You want to predict what? Equations. You want to predict the equation there. Now that we've trained the data, we've trained the combined set. We've trained the combined set in a way that we wanted only the unique characters. We don't want to train a large set of data, because training a large set of data takes a lot of memory, and it can slow down your system. Let's say a user enters an ingredient and the system is so much delayed to bring out the output. It's been frustrating. So we just try to streamline our data into small. So just look at this. We have over 39,000 and just some unique characters, or just 2,970. This is so good. Now after getting all this, we train them. So how do we start training? We start training by using the X train and the Y train. So first you do X train, you do X text, and Y train, and what's Y test. Then from our input that we imported something called train text split. Just enter that one. Then you can see from here, we need arrays for the first one. So arrays or any for the first one. The text size, a float, that's a floating number. We take a percentage. We can just leave anyone, but the next one will be a random state, which takes the number of samples that we should randomly move by. And we have the Boolean shuffle. All this, so the shuffle will just re-updates our system anytime we call it. So the first one is what? The arrays. So we have two arrays here. We have the X and Y arrays. And our next one is the text size. So our text size will be yes 20% because we want to train our data with so much data, and test it with like the later that we have, because once the train is so good, the testing will be so correctly done. So once we train our data, large sample size of data, we can now predict using small text sample size. Then our next one is a random state. So as I explained earlier, random state refers to the sample iterations that we should get. So 42, or we can test data, but I like to take my data to 42. I don't know why, but that's 42 for now. So we should enter and iterate. Now let's see if our trained data set really understand what is going on. So we do this by doing X string, and once we enter X string, we should get a data, right? We should get ingredients, like full ingredients, full set of ingredients, because we are training this X to be the end. So uniquely, we should get full set of ingredients that are unique. So shift enter, and this way we can pass predictions, or we can train X. After training the X, then use the X for the what's the model and learning. Then after I can do the predictions. I know there's a whole lot of things that I'm saying, but you'll get it here. So from here we can see that we have TDF vectorizer, English, this, but we only navigated to this combined ingredients. This will work fine. This will work fine. But logically, for codes to be really readable and understandable, we just have to copy this one. Then instead of this combined X, I'm changing a thing with the same thing. Then put this X here so that this X will be reinitialized. Yeah, you can use it here, which is fine. But also we change this X data to TDF IDF data. Then we run this. So when we run this, it will work perfectly well because our data is now trained, it's initialized. We train the X combined data, and we initialize it, we train it with a vectorizer. Then we obviously know that we'll be getting what the matrix, the 2x2 matrix, and we can test this by doing X6 system 6.shape, and once we run, we get the same data, nothing changes. But our main interest will be here. That's the training. Once we train, test the data set, we see before using this XS, yes, this data, this kind of data set that we are referring to, this with a plain text. There's no mathematical concept added to it. So here's the place where we added mathematical concepts, right, to the text data. So to use that one, you have to use this XTDF to place this. Then train that one, the X. So we can equally test for Y train, then it's produce all the closeness because it's known, the data has already been trained and it knows the output. Like, the output is known. It knows the output that will be produced whenever we enter the data. So, and also we do X train, which will produce the number of combined total frequency inputs and whatever. So you can see that we have 3 by 3 or 2000 unique. These parts of the class, but they already compressed to new formats, right? So our X data, our X train now has been transformed to mathematical concepts, and we can work with it. So our next step is training the classifier or model so that we can test, train, and validate the model, right? Whenever an ingredient is needed. So the main motive here is that we have to train a model because we cannot always write in the same code, always working. So we just train a model. We trained a model